Here we can see that when we multiply a number 2 or 3 or 4 times or n times, what happens to that number? So we are basically dealing with these studies. So first we know that 2 to the power 3, I can call him 2 cube. 2 cube is nothing but it is 2 multiplied with 2 multiplied with 2. Similarly 2 square, 2 square that is equal to 2 multiplied with 2. What is 2? 2 raised to 1, that is 2. Now next I have 2 raised to 0. 2 raised to 0, that is equal to basically any number to the power that is 0, we are picking that number to be 1. So 2 raised to 0, that is equal to 1. So what is 3 raised to 0? 3 raised to 0, that is also equal to 1. Now we know that 3 raised to 1, that is equal to 3. Similarly 3 square, that is equal to 3 into 3. 3 cube, that is equal to 3 into 3 into 3. So the term above the 3 we are call him as power, and the base term we are calling it as base itself. This entire stuff 3 raised to 3 we call him an exponent. So we can see in general results. First x raised to 4. What's the definition of x raised to 4? X raised to 4 can be written as x into x into x into x. So what is a raised to 4? It is a into a into a into a. Here dot I denote for multiplication. So don't confuse with your cross and dot. I will use both stuffs. Now next I have b raised to 5, which is equal to b multiplied with b multiplied with b 5 times. Okay. Now here I have a into a into a. Here I have a into a into a. So how can I say, how can I multiply these two terms? Here we have a into a into a. What is a into a into a? A cube. What is a into a into a? Which is a raised to 4. So what is a cube into a raised to 4? So we are going to see such type of results. So let us see some illustrative example. 2 raised to 5. What is 2 raised to 5? That is equal to 2 into 2. We are multiplying 2 5 times. Okay, that is 2 raised to 5, which is equal to 32. Now, what is 2 square? We are multiplying 2 times. That is equal to 4. Now, what is 2 raised to 5 into 2 square? We have seen that what happens when a into a into a multiplied with a into a into a. So, this is of the form a cube into a raised to 4. Similarly, here we have 2 raised to 5 into 2 raised to 4, 2 square. So, in such case, I am doing what my method is. Here we know this is 2 raised to 5, that is 32. So, 32 into 4, and that is equal to 128 in one way. In other way, I can do something more. I can, if I have same exponents, that is 2 raised to 5 and 2 raised to 4, the base terms are same, I can add the powers. Here we have the base term as 2 and 2 and the power term is different. So no harm, you can directly add the powers. So 2 raised to 5 into 2 raised to 2 square, that is 2 raised to 5 plus 2. So 2 raised to 5 plus 2, which is equal to 2 raised to 7. And we know that 2 raised to 7 is nothing but 128, which is equal to 128. Let's go for another examples. So in general, I conjecture a result, the so-called a raised to m multiplied with a raised to n, which is equal to a raised to m plus n. If you have same base and different powers, you can always add the powers. Okay, that's our result. Now, what is a raised to m? We can go for some examples. First, 3 square multiplied with 3 raised to 5. You have same base, you have different powers. So what is the answer? 3 raised to 2 plus 5. We have 3 raised to 2 plus 5, which is equal to 3 raised to 7. Another one, 5 square multiplied with 5 cube. You have same base, different exponent. You can add powers. So 5 square into 5 cube, which is equal to 5 raised to 2 plus 3. 2 plus 3, which is equal to 5 raised to 5. Sorry, that was actually 5 raised to 5. Next one, here you have 7 square and you have 7 cube. So you can add the powers. So 2 plus 3, which is equal to 2 plus 3, which is equal to 5. So you have 7 raised to 5. Here you have 13 raised to 7. Here you have 13 square. Same base, different powers. So you can add the powers. So that is equal to 13 raised to 7 plus 2, which is equal to 13 raised to 9. And here you have it is 2 plus 3, and that is equal to 5. It's not 7, it is equal to 5. So this is how we add powers. If you have same base and different exponents, you can always add the exponents. Okay.